Good morning, everyone. It's day 3, so been gone for a couple of days now. We're going to talk about lesson 11.3, which is geometric sequence today. Today's lesson should feel very similar to the one that we learned 2 days ago, so hopefully it'll go much quicker than the last couple. A lot of time in 11.1 and 11.2 was setting up groundwork and getting things ready. Most of our time in this one is just going to be diving in, so hopefully a lot of you will be able to get into this lesson early and get this homework done before you leave from class at the end of the hour. So today we're going to talk about geometric sequences. Just a reminder, a sequence is a pattern of numbers. Arithmetic sequences were number patterns where we added or subtracted between terms. So now geometric sequences are number patterns where we will multiply or divide between terms. Now, just like back in arithmetic sequences, when they subtracted between terms, they really called that adding a negative. When we're multiplying between terms, but it's shrinking, so we're dividing between terms, they're really going to call that multiplication by fraction. So the book's going to set up as always being multiplication, but sometimes it'll be multiplication by a whole number, and sometimes it'll be multiplication by a fraction. I want to look at 2 quick examples here and talk about the patterns. So this looks really similar to one of the arithmetic sequences we were working with lately, which was 2, 4, 6, 8, 10, etc. However, instead of adding 2 each time, on this one we're multiplying by 2. 2, 4, 8, 16, 32. Times 2, times 2, times 2, times 2. That times 2 pattern is called our common ratio. That is the number we are multiplying between our terms. Now, if you're having a hard time finding your common ratio, Mr. P always recommends to divide backwards. So, if I take any 2 values in the sequence, let's say I'm going to use 32 and 16. Any 2 values side by side will work. I'm going to take the one that's furthest down the sequence and divide it by the one behind it. So 32 divided by 16 is 2. That gives me my common ratio of 2. So if I'm stuck and I can't find my pattern, that's the easiest way to find it. Now over here I've written another geometric sequence where the pattern is a little bit harder to find. So I'm going to do the same thing. I want to know what my pattern is, or my common ratio. So I'm going to take any 2 values in the sequence, 3 and 9, and divide them backwards. 3 divided by 9. Now a lot of you saw immediately 9 divided by 3 is 3, which is true. And if you can take that and then invert it or create its reciprocal, you do have the pattern. But for those of us who didn't see that quickly and easily, just divide it backwards. So 3 divided by 9 reduces down to 1 over 3. 1/3 ends up being my pattern. 1/3 of 81 is 27. 1/3 of 27 is 9. 1/3 of 9 is 3, and 1/3 of 3 If I were to go further, I'd end up at 1/3, because 1 times 1/3 is 1/3. So over here we have a number pattern, and the book has asked us to find the next terms. Find the next 4 terms and r. So in order to find the next 4 terms, we're going to have to find r anyway. So we have 5, 20, 80, 320. Now if I don't immediately know my pattern, I'm going to take 2 terms in my sequence and divide backwards. 20 divided by 5 is 4. Now I know my common ratio is 4. So if I want to find the next 4 terms, multiplying by 4 each time, I do 320 times 4, which is 1280. 1280 times 4, which is 5120. 5120 times 4 is 20,480. And 20,480 times 4, which is 81,920. You can see that these numbers are getting quite large very quickly. That's the biggest problem with geometric sequence versus arithmetic. So with an arithmetic sequence, if I want to get to the 40th term and I'm adding by 2's, I'm not going very far. I'm going to only go about 80 values, because 2 times 40 is 80. Even if I'm adding by 5, if I'm going 40 terms, I'm still only going about 200 numbers away. When you want to go out 40 terms on a geometric sequence, the number is going to get massive. So a lot of times the book won't give you very big n's in this section. They'll keep n to less than 20, usually. Now, Mr. P doesn't always guarantee that. Sometimes I blow my n's up and you get some goofy numbers on your calculator, and I'll talk about that when we get to that closer to the test. But usually the book is going to keep your n's reasonable, but that doesn't mean you should just multiply them out or count them out. Make sure that you get proficient using the formula, because if you can't use the formula, then you might get yourself into trouble. Alright, so we have another example here where it tells us our A1 is 7, our N is 4, and our R is 2, and we'd like to get out to the 4th term. We want to know what the 4th term is. And we could do that. We could do 7 times 2, and we do it 4 times, and we'd end, or 3 times, and we'd end up at the 4th term. But we're going to use our formula, which is written across the top of the board here. AN equals A1 times R to the N minus 1 power. Now it's really, really important that we understand the pieces of the formula. So let's talk about them. AN and A1 should be familiar. AN is our last term, or what we're looking for. A1 is our first term. And N is the number of terms that we're counting out. So it's just R that's new. And R pretty obviously stands for our common ratio. In other words, what are we multiplying by each time? So let's put our information into the formula. Now this, unlike yesterday's lesson, won't be missing multiple pieces. You're going to have everything you need to finish the formula. It could be tricky. The trickiest one is when you're missing n. If you're missing n, that gets a little tricky. Okay? But as long as n's there, it's usually not a big deal. And you'll be able to put your pieces together. If n is missing, you might have to think about it a little bit. So those ones would challenge you. But if you're missing r, a1, or an, you should be okay. But we'll work through that if it comes up. An is the what we don't know in this case, which is the best case. A1 is 7, r is 2, and our n is 4. And it would be 4 minus 1 up here, which will be 3. So I end up with an equals 7 times 2 to the third. Now remember your order of operations. You must do 2 to the third power before you multiply to the 7. You cannot multiply the 2 and the 7 to get 14 and then take it to the third power. That will give you a bad answer. We do 2 to the third power, 2, 4, 8, then we multiply to the 7. 7 times 8 is 56. 56 is the fourth term of that sequence. Alright, while you're writing that down, I'm going to set up a couple of homework problems that we're working on. And then I'm going to let you guys get to work. By the way, the homework is on page 667 for those of you who have already copied everything down. Alright. I'm going to start with problem 18 and 28. And then I'm going to do one more. I'm going to do problem 37 when we're done. But I'm going to clear some space over there when I go to do it. So hopefully everybody's got everything over there alright. Problem number 18 asks us to find the next 3 terms in the sequence. In order to do that, I need to know what I'm multiplying by each time. The trouble with problem number 18 is that it's shrinking. And it's shrinking at a rate that is difficult to see. This is exactly the type of problem I'm talking about where r can be tricky to find. So we're going to take any 2 numbers in the sequence and divide them backwards. 135 divided by 405. You go ahead and do that in your calculator. You will get 1/3. So that tells us we're timesing by 1/3 each time. So then we can continue this out. 45 times 1/3 is 15. So 15 is the next number in our sequence. 15 times 1/3 is 5. So 5 is the next number in our sequence. And 5 times 1/3 is 5 thirds, or 1 2/3, which is the next number in our sequence. 1.6 repeating, if you had that in your calculator. Okay? Number 28. Number 28 gives us the pieces A1, N, and R, which are excellent. That's exactly what we want. So let's remember our formula. AN equals A1 times R to the N minus 1. AN equals 1/64 times R 4 to the N minus 1, 9 minus 1. AN equals 1/64 times 4 to the 8th. Again, we need to be able to do our power. We need to do our power first and then multiply it. So we do 4 to the 8th power. which is 65,536. Then that can be multiplied by 1/64 to give us 1,024. Hopefully that worked okay for everybody. Remember to do your power first, and then after you're done with your power, you can multiply. If I had times that 1/64 by 4 first, I would have gotten the wrong answer. Alright, the last problem I'm going to work on is one of these weird ones with geometric means. In other words, missing pieces. Now most of you on the arithmetic ones probably just figured out how to count in between or left them so that we're parking lotting them later when I get back, which is fine, either way. But the goal was for you to use the formula to find out what your common difference was and then find the missing pieces, which is what I told you in the video. On this one, it's trickier though to do geometric ones. So I'm going to walk it out with everyone so that we can find our common ratio and then work our way back to our gaps. So our formula, again, is AN equals A1 times R to the n minus 1. Now, we know a few things. First of all, AN, the last term, is 144. A1, the first term, is 9. R is our unknown, but n is 1, 2, 3, 4, 5. That is the number of terms that we have. 144 equals 9 times r to the 4th. Now our next move is to get that 9 over to this side. And we need to do so by division. So 144 divided by 9 is 16. Now some of you are already seeing this because we've been working on this earlier, but 16 is what number to the 4th is what this says. The way to get it is to 4th root, or do 16 to the 1/4 power, if you'd prefer, but the 4th root of 16 is 2. So r is 2, because 2 times 2 is 4 times 2 is 8 times 2 is 16. They're going to give you nice numbers for the most part. They may give you those nice numbers in fraction form. So you may have 1/2 or 1/3, or you'll have 2 or 4, but you're not going to have anything super crazy. Now that we know r is 2, we can go back up into the sequence and fill in our missing gaps. 9 times 2 is 18. 18 times 2 is 36. 36 times 2 is 72. 72 times 2 is 144. Hopefully that went well and made sense to everybody. Have a nice day, and I'll see you tomorrow.